Rajasthan Higher Maths Paper 2017, question number 2. In question number 2, we're given the series 2 plus the square root of 2 plus 1 over the square root of 2 plus a half plus 1 over 2 root 2 and so on. We're also given the equation, the cube root of 1 plus x plus the cube root of 1 minus x equals the cube root of 2. Now in part A, we're asked to express 0.12 recurring, that is 0.121212 and so on, as a rational fraction. Now, to do this, let x equal 0.121212. And because there are two numbers that are recurring, we multiply by 100. So 100x equals 12.121212. And if we write below x equals 0.121212 and subtract, we find that all the decimal digits will cancel out because they're the same. So we'll have 99x equals 12. Well, if we divide by 99, x equals 12 over 99, which cancels to x equals 4 over 33. So our answer is 0.12 recurring is 4 over 33. Now, in part B, we're asked to find the seventh term and the sum of the given series 1 up to infinity if it exists. Now to do this, the first term is a equals 2, and the common ratio is the second term divided by the first term. So the common ratio r equals the square root of 2 divided by 2. But we can simplify that because on the bottom 2 can be written as the square root of 2 times the square root of 2. And then you can cancel the square root of 2 top and bottom, and that leaves r is equal to 1 over the square root of 2. So if we use the formula for the nth term, which is equal to a r to the n minus 1, then we have the seventh term is equal to the first term 2 times the common ratio 1 over the square root of 2 raised to the power n minus 1, which is 7 minus 1, or 6. So the seventh term is equal to 2 times 1 over the square root of 2 all to the power 6. Now, 1 over the square root of 2 to the power 6 is a half cubed, which is 1/8. So the seventh term is 2 times 1/8, or our answer is the seventh term is equal to a quarter. Now, the sum to infinity is given by the formula a over 1 minus r, where a is 2. r is equal to 1 over the square root of 2, which is less than 1, and so the sum to infinity does exist. Substituting, we get the sum to infinity is 2 over 1 minus 1 over the square root of 2, and if we multiply top and bottom by the square root of 2, we get the sum to infinity is equal to 2 root 2 over root 2 minus 1. Now we could leave that as our answer, but we can multiply top and bottom by the square root of 2 plus 1. And this gives us the sum to infinity is 2 root 2 times root 2 plus 1 over root 2 minus 1 times root 2 plus 1. Now on the bottom we've got the difference of 2 squareds. So this simplifies to, on the top, 2 into 2 plus root 2. And on the bottom we've got root 2 squared minus 1 squared. Now root 2 squared minus 1 squared is simply 2 minus 1. So the sum to infinity is equal to 4 plus 2 root 2 over 2 minus 1, which is the sum to infinity equals 4 plus 2 root 2. Now, in part C, we're asked to solve the equation 2. So we have the equation is the cube root of 1 plus x plus the cube root of 1 minus x equals the cube root of 2. Now we can use the result that a plus b all cubed is equal to a cubed plus 3a squared b plus 3ab squared plus b cubed. And we can cube both sides of the original equation. So the cube root of 1 plus x plus the cube root of 1 minus x all cubed is equal to the cube root of 2 all cubed. And that expands out as 1 plus x plus 1 minus x plus 3 into 1 plus x all to the power 2/3 times 1 minus x to the power 1/3 plus 3 into 1 plus x to the power 1/3, 1 minus x to the power 2/3 equals 2. Now the first two terms in that simplify to give the number 2. And the number 2 can cancel on the left and the right hand side. We can then divide both sides by 3. And so we're left with 1 plus x to the 2/3 times 1 minus x to the 1/3 plus 1 plus x to the 1/3 times 1 minus x to the 2/3 equals 0. Now if we put those two terms on either side of the equation, that gives us 1 plus x to the 2/3 times 1 minus x to the 1/3 equals minus 1 plus x to the 1/3 times 1 minus x to the 2/3. And then we can cube both sides. So 1 plus x squared times 1 minus x equals minus 1 plus x times 1 minus x squared. If we put them all onto one side, we get 1 plus x squared into 1 minus x plus 1 plus x into 1 minus x squared equals 0. And then we have 1 plus x and 1 minus x as common factors. So taking them out as a factor, we get 1 plus x plus 1 minus x into 1 plus x into 1 minus x equals 0. Now the terms in the square bracket cancel down to 2. So we're left with 2 into 1 plus x into 1 minus x equals 0. Now if two terms multiply to make 0, one of them must be 0, so x plus 1 is 0, or x minus 1 is 0, so x is equal to plus or minus 1. Now if we want to, we can check this result. If x is equal to 1, the left-hand side is the cube root of 1 plus 1 plus the cube root of 1 minus 1. And that's equal to the cube root of 2 plus the cube root of 0, which is equal to the cube root of 2, which is equal to the right-hand side. If x is minus 1, the left-hand side is the cube root of 1 plus minus 1 plus the cube root of 1 take away minus 1. Now that simplifies to cube root of 0 plus the cube root of 2, which is just the cube root of 2, or the right-hand side, and so x minus 1 is also allowed. So our answers are x equals 1 or x equals minus 1.